Hi everyone, today we are diving into an essential topic for any projects that deal with data. We will talk about data quality. My name is Alex, I am professional manager and I am here to share my thoughts and knowledge about management and tech with you. But before we start, let me tell you something. Several days ago, I ran into an issue. I was trying to log in into my university portal to check my grades. Pretty simple, right? But no matter what I did, I couldn't log in. At first I thought, did I mess with my password? But the password was fine. I tried different browsers, cleared my cache, nothing worked. Finally, I opened DevTools, and guess what? The problem wasn't even on my side. It turns out that my course, which is academic level, wasn't defined, and it broke login process. That got me thinking about how important the data quality is. Everything starts with a solid data management plan. Think of it as a blueprint for how you will handle, process, and store data. It is what keeps everything organized and on track, especially on a big projects. When you create data management plan, start with scope and purpose. You should focus on every step on the data's life, from collection to eventual disposal. Define this section so everyone will be aligned on the goal of the document. The second section of your plan answers to the questions: how do you typically collect data, what tools do you use, and how do you ensure it is useful? From the screenshot you can see that we work with a variety of data types, such as student grades, surveys, and historical records. Some of this data is collected automatically, like scores and attendance, while other pieces require manual input. In the section 3 you will specify the types of databases you are using and their purposes. Along with that, you should define rules for how to store data, create hierarchy, and point out where and what data should be stored. This will help establish a clear approach, ensuring there is no confusion in the future. Additionally, you can specify policies of storages and encryption methods. As for data processing part, I believe there is no need to specify your data pipelines and actions in details. Instead, focus on creating a high-level steps how your company typically approach data processing. In the next section, you need to consider roles and access level. Make sure to comply with company regulations, ensuring that each user has access to only what they need. Use the principle of least privilege to restrict accesses to sensitive information. Also, keep in mind that when data has served its purpose, it doesn't simply disappear. There are several methods for handling this, and two of them are as follows. Finalized datasets can be moved to a long-term storage such as S3 Glacier, Deep Archive bucket, or the data can be securely deleted, ensuring no trace remains. The approach you take will depend on your company policies and regulations. By the way, it is important to define roles to manage data, coordinate with the team members, and address data-related issues efficiently. At the end, I would like to include a change tracking section to monitor any modifications made to the data management process. This will help you to track changes and contact the responsible individuals when needed. So folks, we have completed data management plan part, and now I would like to dive into a practical example of how to apply its steps to ensure data quality. Let's imagine the initial student registration data was collected by using paper forms. A technician then manually transferred this data and stored it directly in MongoDB. In the MongoDB, we have a database called University with a collection students. Our data structure looks as follows. We have generated ID by MongoDB, we have student ID, we have student first name, student last name, academic year, password, email, registration date, and our goal is to validate and clean this data, then load it into PostgreSQL and make it available for the registration process. Alright, let's dive into the details. I've already prepared the code, so we will simply execute it and review the results. First thing first, let's connect to our MongoDB instance and initialize the client. Great, our connection is successful. Let's move forward and execute next cell. In our next cell, we connect to database, then to the collection and retrieve the data from the MongoDB. We will be able to explore our data as a data frame with its all characteristic. Student ID, student first name, last name, academic year, password, email, registration date. So far so good guys, but before going any further, we will need to concentrate on our cleaning and transformation step. We will need to check that our password do not contain null values, our academic year falls within specific number range, Then we will need to delete duplicates and drop all data before 2010. As we have a plan, let's jump into the code. Based on the data cleaning rules, we will first examine our data to determine how many rows require cleaning actions. So let's execute our cell and check data below. As you can see, 6 null values only for password field, 0 invalid values for academic years, 2 duplicates of student IDs, and 2 registration dates older than 2010 that require deletion. Let's proceed with data cleaning part. In the next cell, we will clean the data based on the rules, generate new passwords for those who had them as null, and gather the email list. Let's do it. Okay, nice, we have executed the cell and we can double check our data one more time. Great, as you can see, there is no null values for any of field, there is no invalid academic years, there is no duplications, and all registration dates fall within specified date range. Just for fun, I also simulated sending of emails with the new passwords. Let's execute this cell as well. And here we go, emails has been sent with the new passwords. Okay everyone, we already completed our data management plan step, collection of data step, and also cleaning and transformation step. And our next stage is to validate the data and generate a report that will confirm that all checks have been passed. For this, we will be using the Great Expectation library. Great Expectations is an open source Python library that provides a flexible and powerful framework for data quality checks and tests. It helps to ensure that our data is accurate, consistent, and meets the expected standards. But before we start defining expectations for our data, we need to transform the registration dates into Unix format, as Great Expectations currently cannot work directly with date fields. So let's execute our cell and check our data one more time. Fine, we can see that our registration date has been transformed. After successful transformation of registration date, we will be able to create a context, then define data source and data asset. After it, we will define our suite where we put all of our expectations. As we discussed earlier, our expectations will be based on our validation rules. Password should not be null, IDs of students should be unique, registration date should fall within specified date range, and academic year should be from 1 to 6. One of our steps is to define the batch which specifies the data we will use for checking against the expectations. Then we define the validation itself. This includes name of the validation, suite name, and the batch name. With this setup, we are ready to run validation. Let's run our validation. And here we go. After running the validation, we can see as an output JSON file that details the final status of the data validation, including the percentage of failed expectations. But let's be honest, it is quite inconvenient to analyze outputs in that format. That's where the Datadogs module come in. It generates an HTML page with beautifully displayed results for easier analysis. So let's build our HTML page and open it. We have been redirected to Datadogs HTML page where we can investigate our results. As you can see, our run with the expectation suite is listed here. Let's click on it and explore the details. We can see that the overall status of our expectation suite is success. Also, 4 of 4 expectations passed successfully. The first expectation about the academic year passed successfully. Passwords have no null values. As for the registration date, all values are within specified date range. As for the student IDs, all of them are unique. Everything looks great, so we can proceed with data loading into Postgres. To insert our data, we need to initialize our connection string and then execute script below. So let's check our results in Postgres. And here we go. After completing data cleaning and validation, we now have our unique students in PostgreSQL. All the necessary fields are populated and fall within the expected ranges as well. We have already accomplished a lot. With the validation and loading steps completed, the final task is to document the results. This could include logs of executed scripts, reports generated by Great Expectations, or any other documentation your company or client may require. Ensure everything is recorded accurately for transparency and future references. I hope you enjoyed watching this video. Let me know what do you think about this approach. Also, don't forget to like and subscribe. See you!